Okay, let's look at this quick video on how to use the present value tables to determine the price of a bond. The first thing we have to take into consideration is what are the cash flows related to the bonds, and usually there are two. One is going to be interest payments. The bondholders are going to get interest payments over the life of the bond. And the second one is that when the bonds mature, the bondholders are going to get the face value returned. And so what we need to do is figure out the present value of those interest payments. And so the first thing that we want to do, and the only time in this calculation that we're going to use the stated rate, which in this case is 8%, is when we figure out the amount of the interest payment. So in this case there are $800,000 worth of bonds, and the stated rate is 8%, and so that means these bonds are going to pay a total of $64,000 of interest annually. Now the next thing that we have to pay attention to is that most bonds pay interest semi-annually. So it's true that over the course of the year these bonds are going to pay out $64,000, but what that really means is in the first half of the year they're going to pay $32,000, and in the second half of the year they're going to pay $32,000. And that's how the semi-annual works. Okay, so we know that we have that cash flow. That each time the company pays interest, it's going to be $32,000. Let me get rid of that. I don't know what that's from. Okay, and then we know the other cash flow is, maybe I'll make a note here. This is interest, and the other one is the we might think of that as the principal or the face value, right? And the cash flow for that is $800,000. Okay, so there's lots of different ways to solve this. The worst way probably is the way that we ask students to do it here, and that is using the time value of money tables. In real life, the way these things are solved at this point is just using Excel, although some may still use a financial calculator. Okay, so when we go and use the tables, we have to ask ourselves, there's some information that we need. And the one is we need to figure out, what is the number of periods and what is the market rate. And those have to be presented in the same sort of unit of measure, or time period. So in this case, we know this is a 10-year bond, but in over 10 years, the company is going to make 20 interest payments, right? Because they're going to make interest payments semi-annually. So the answer to this is the number of periods is 20 periods, 20 semi-annual interest payment periods. And now, what is the market rate for those? Well, we kind of do the same thing here, right? If the market rate is 10%, that's 10% annually. So what that really means is 5% in the first half of the year and 5% in the second half of the year. Another way to think about that is when it's semi-annual, we double the periods and half the rate. And the rate we use is always the market rate. Okay, now I have the information I'm looking for. 20 periods, 5%. So what tables do we use? Well, we need to figure out when the timing of these cash flows happen. So the interest gets paid every 6 months for 20 periods. Well, we call that an annuity. So the interest is an annuity, and the principal is a one-time payment. So we commonly refer to that as a single sum. Alright, so let me erase that. and we'll take a look at the table. So I'm going to open up the tables now. Alright, so this is a common table here. This is present value of $1, or sometimes called present value of a single sum. What it means is it's a one-time amount. And remember, I've doubled the periods and half the interest rate. So 5% for 20 periods. And if I can do that correctly, that tells me that the present value factor that I use for my single amount is 0.377. So let's go back and put that into our equation. So I take the 800,000 times 0.377, and that gives me 301,600. So the amount of the principal of the bonds, which are going to mature in 10 years at 800,000, is really worth 301,600 in today's dollars with an interest rate of 10%. Alright, so let's go look at the cash flows for the interest payment. In this case, I'm using the present value table of an annuity. So an annuity means regular payments. And again, I use the same rationales before. So it's 5% for 20 periods, and that gives me 12.462. So let's use that factor in our calculation. So I multiply 12.462 and I get 398,784. Looks like I've run into some stuff there. Okay, so now I can total that up, and when I total it up I get 700,384. So it means that the $800,000 worth of bonds will sell for 700,384, meaning that they will sell at a discount. Now, we already knew that they were going to sell at a discount just because of the rates. Our bond is only going to pay 8%, but the market rate is 10%. So the way that we are going to entice people to buy our bonds is to discount the price. And then, of course, we would commonly be asked to make the journal entry here. So let's go ahead and do that. Okay, and I think the date was January 1. On January 1, we issue these bonds, and so we would debit cash for 700,384. We would credit bonds payable for 800,000, because when they mature, the amount that we owe our bondholders is 800,000, and the difference of 99,616 is a debit called, I don't have room to write it all out here, but it's a discount on bonds payable. And that would be what we would issue. And then, of course, I've prepared a video showing you how to do the effective interest rate amortization table for a bond like this.